you want to, you can ask me.
Now, this is a sketch of a graph. So this is not the actual standard graph you know. It's just a sketch. Now, we want to use this sketch and learn a lot of things in graph plotting of this experiment. So first thing you have to do is write the date. I always say it in all the videos I've been talking about. Write the title. A graph of what are you plotting? A graph of M in kg against Y in meter. Please write the title. Now, next is choose appropriate scale. We have posted videos, a lot of videos on how to choose appropriate scale. So do well to click on our YouTube, Chidon's Daniel, how to choose appropriate scale. Click Chidon's Daniel, how to choose appropriate scale. You see plenty videos we have posted there on how to get error in slope, in intercept, all of them you will see them there. So do well to what? Click it. Okay. Then next thing we have to do is we now say, how do we choose our what? We label our Cartesian axis. We call here our M in kg and our what? Y in meters. Now we have 1, 2, 3, 4, 5, 6, 7. If we say 0 here, 0.1, 0.2, 0.3, 0.4, 0.5. Wow. And the highest we have here is 0.5 for M. So we can say, should we plot from 0 from origin? Is left for us because it was not instructed. Okay, let's check this too. Should we start from origin here too? Let's check. So if I say 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 6 will be giving me 54. Oh wow. 9 times 3, 27. So 9 times 4, 36. We can go by 0.04. We just say, if I start 0.0 here, if I wish to start 0.0 here will be 0.10, 0.20, 0.30, 0.40, 0.50. So the idea of choosing appropriate scale is to choose a number that will accommodate in the graph, such that the difference between each of them will be giving you the same thing. Are you getting it? And so come to this side, we'll be choosing 0.04, 0.08, 0.12, 0.16, 0.2, 0.24, 0.28, 0.32. Okay. 0.08, 0.16, 0.12, 0.16, 0.20, 0.24, 0.28, 0.32, and 0.36. The highest is 0.33. So we have choose our appropriate scale now so that it will balance. We plot 0.1 against 0.7. 0.7 will be close to 0.8. We put. So use your standard graph sheet and see that you trace it well and plot it, okay? 0.2 against 0.13. Look at 0.12, so 0.13 will be here. Then 0.3 against 0.2, that one is perfect. 0.4 against 0.26. This is 2.4. So 2.6 will be in between. 0.5 against 0.33. This is 0.32. So 0.33 will be somewhere here. So we have located our points. Next is to draw our line of best fit. Okay, we have located our line of best fit as you can see on this graph. Now, next is to get our slope. To get our slope, we draw our vertical line. So, we are drawing our vertical line, then and our horizontal line. So, we say change in M equals to, this point is about 0.49 minus this point is 0.10. This point is change in Y equals to 0.32 minus this is 0. Let's say 0. What 06. 0 since here is 0.07, so 0.06. Then we use our calculator and say our slope is equals to change in M all over change in Y is equals to 0.49 minus 0.10 all over 0.32 minus 0.06. Okay, let's check. Equals to 0.39 all over 0.26. That will be giving us 0.39 divided by 0.26, 1.5. Vertical is kilogram, horizontal is meter. Now, because they say we are to do the one of 2, but because they say deduce the value of young modulus E from the two graphs. So from this graph, our young modulus, since we said that Y is equals to Km, making M subject of formula, we have that M is equals to what? Y times inverse of what? K. Y times inverse of what? K. Where you are plotting the graph of M against Y. When you plot the graph of M against Y, 1 over K will be the slope and it's passing through the origin. Let's check it. Y times 1 over K simply means 1 over K bracket Y. And so we have to clean everything and package it well and say equals to 1 over Y, 1 over K. Are you getting it? We have it this way, where the slope will be inverse of what? K. Your slope, which is K, whatever is your slope, will be inverse of K. Okay, now we said that K is equals to GL cube M GL cube all over 4 BT cube E, all over 4B cube E. Now from here we said Y is equals to Km and K is this. That means Y will now be equals to what? Y is equals to this times what? M. Are you getting it? We make E subject of formula. We make M subject of formula. M will be equals to M equals to 4bt cube what? E y all over what? G L cube. We have it this way. That means when you plot the graph of m against what? Y. This becomes your slope. This becomes your slope. Are you getting it? This will be your slope. And that your slope is equals to 1 over k. That your slope is equals to 1 over k. 1 over k. So what is our slope? Our slope is 1.5. We say 4bt cube E all over GL cube is equals to 1.5. Because the slope, which is 1 over k, is gotten to be 1.5. We make our E subject of formula. Making our E subject of formula, we have that E will be equals to, this times is 1.5 GL cube all over 4bt cube all over 4bt cube. So when you compute this, whatever it gives you becomes your answer. Let's compute it. We say 1.5 times 9.8 times 0.75 raised to the power of 3 equals to this, divided by bracket 4 times, what is our B? 0.025 times 0.005 raised to the power of 3. So that will be giving you 496,125,000. We tell them that our E for this is equals to 496,125,000. That means Newton per what? Meter square. 1, 2, 3, 4, 5, 6, 7, 8, 9. 496,125,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That means equivalent to 0.496, or if you know that when you approximate it now to one decimal place, what will it will give you is 0.50, right? 0.50 times what? 10 raised to the power of 9 Newton per meter square. That is the value of A you have gotten. That means from principle of bending or depression, you can get the E of a meter rule. You can get the E of a meter rule. Remember, 1.5 is our slope times G, 9.8 times L, which you say is 0.75, times B, all over 4B. B is 0.025, T is 0.05, then T is 0.005. Please, T equal to 0.005. B equal to 0.025, etc. And so you cube it, then you get your answer. We want to plot the second graph now. That is a graph of m against t square and obtain its slope. We say here, the date, you write your date. We'll name the title a graph of what? M in kg against t square a second squared. So once you have labeled it, we are plotting m now against t square. Now we can say let us start from the origin for y. Let's start from the origin for y. This is your y. 0.10, 0.20, 0.30, 0.40, 0.50. Now label your Cartesian axis appropriately. This is mass in kg, while this is t square in second squared. Are you getting it? Then for your x axis, if we say let's use 2 now, for instance, to watch how we are taking this scale, watch it on our channel, Chidon's Daniel, how to choose appropriate scale, so that you see the manipulations that are being done there, how to get it sharp sharp. But at this point, I'm not going to be doing such thing often and often. So over and over again, so I just want to do it as fast as possible now. We have t square 4.26, 8.53, 12.79, 17.06, 21.3. If I go by 2, 4, 6, 8, 10, 12, 40, it can go. Then I can say let me go by 4. 4, 8, 12, 16, 20, 24. It will go. So 4, 4.0, 8.0, 8.0, 12.0, 16.0, 20.0, 24.0. So the scale you use depends on the standard graph you are using and how many big bars you can see there. This is just a sketch of the graph. Are you getting it? So use your own to see what it will give you. That means we are starting from 0 2 for the x. This is for x and this is for y. Okay? Then 0.1 against 4.26. Wow. Against 4.26. Look at 4. 4. Look at 8. 8 minus 4 will give you 4 divided by 10, 0.4. So if we have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 over 10, 0.4, right? 4.4. 4.4 will be the next, but here is 4.26. So we now say it will be here. Then 8.5. 8.5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8.5. The next one should be 8.4. So 8.4. But what we need is 8.5. We'll take it like this. Then what else? 0.3 against 12.8. 12.8 should be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 12.4, 12.8, we can get it. Then we take again 17.06 against 0.4. 17. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. 16.4, 16.8, 17.2. So like this. So 17.2, it should be less than 17.2 because what we can get is 17.2, not 17.06. 21.32, 21.32. This is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 20, 20.4, 20.8, 21.2, 21.6. So around here. Okay. So we are finished sketching the points now. Let's draw our line of best fit. Okay. Wow, we have drawn our line of best fit now. We can see only one fell out. So what we have to do now is we get our slope. Let's get our slope. Okay, so it starts from here, end here, then end here. So we say here is change in M. Change in M is 0.55 minus 0.1. Then here is change in what? T square equals to, change in T square is equals to 24 minus 4.0. So we say slope equals to change in M over change in T squared. What is change in M? This minus this, 0.45, all over this minus this is what? 20. What will it be giving us? We'll be having 0.45 divided by 20 equals to 0.0225. 225. What is the unit? Kilogram per what? Second squared. So that is the slope. That is the slope we get from this graph. But they say also deduce the value of your modulus A from this second graph as well. Okay, to deduce it, recall that we said that T square is equal to Km. That means making M subject to formula, M equals to 1 over what? K times T squared. Times T squared. That means what is our K? We say our K is equal to 16 pi square L cube all over B T cube what? E. All over this. And when we finish plotting this, that means what is K now? What is our slope? We say this is our slope, but K is 16 pi square L cube all over BT cube E. Since T square is this, what will be your T square? T square will be equals to 16 pi square L cube all over BT cube E times what? M. Now making M subject to formula, this will go here. Making M subject to formula, this will go here. You will now see that M will be equals to this times this, BT cube what? E all over 16 pi what? Square L cube. So this times this is T squared. So when you have gotten this, it means that when you plot the graph of M against T square, this will be your slope. And what is our slope? 0.0225 is equals to BT cube E all over 16 pi square L cube. Are you getting it? Making E subject of formula, therefore E is equal to this times this 0.0225 times what? Times 16 pi square L cube all over BT cube. Okay? So let's get what our E will give us. We'll use our calculator. 0.0225 times 16 times shift pi squared times our L is 0.75. It's constant 0.75. 0.75 raised to the power of 3 divided by bracket Our B is 0.025, is constant. We got it using vernier caliper, times our thickness is 0.005, 0.005 raised to power of 3. So when you compute it, you'll be having that your E is equals to 479,662,773.9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the unit is Newton per meter squared, because we put everything in SI unit. Newton per meter squared. Yes. Now, approximately, our E will be equals to 0.5. 0.5 times 10 raised to the power of 9 Newton per meter squared. That means from these two experiments we just concluded, when you use the first approach to perform this experiment, the young modulus you will be getting will be similar or nearly equal to the young modulus you will get when you use principle of oscillation, principle of bending moment, principle of bending or depression, and the principle of oscillation. The young modulus you will be getting from the two will be what? If not exactly the same, will be similar or nearly equal to. Okay, so that means there are many ways you can get young modulus using of bending moment principle, cantilever, that is using principle of depression as well, and using principle of oscillation. You can get young modulus of that meter rule. Remember we said the lower the young modulus, the lower the value of the young modulus of that word meter rule, is telling you that that meter rule is flexible. The more flexible it will be. The higher the young modulus, the more stiff it will be. So the higher, the more stiff; the lower, the more flexible. Okay? Yes. Please note it. Remember we said you can be asked to write precaution. If you are asked or if you are not asked, please include your precaution. And we mentioned one of it, that the that care must be taken to see that this why depressing this meter rule, that you depress it at what? At a small angle. Are you getting it? You depress it at a small angle so that to minimize error, because when you depress it at a small angle, are you getting it? When you displace it at a small angle, it will be rotating slower, and so you can count your 10 oscillation. But when you displace it at a higher angle, you see it moving fast, oscillating fastly, and so you may find it difficult to get the actual oscillation given to you. Maybe by the time you're about to pause your stopwatch, it has even reached 15 oscillations, or it has not reached. So to be on a safer side, displace it at a very small angle. If you find this video very interesting, please don't forget to like the video, click subscribe, share to your friends, comment. Yes, comment. Tell me your opinions, tell me your challenges on the comment box so that we interact together. Thank you once again for believing in my service.